Okay, for these last examples, we're going to look at variations on the converse of the Pythagorean theorem. So in this problem it says, can the lengths shown form form a triangle in general? So what we want to do first is see if it forms a triangle. If it does, we want to show, is it acute, right, or obtuse? So first of all, the triangle inequality theorem tells us to take any two sides, add them together, and see if it's bigger than the third side. In this case, we can look at it. Remember, I told you all you need to do is look at the two smallest sides, see if it's bigger than the biggest side, because it's kind of a waste to do all three sets. So we add these two, we get 9.5. We can see that that is bigger than 6.1. So yes, we can say the lengths form a triangle. If it didn't form a triangle, we'd be done with this problem. But it does form a triangle. So we're going to see, does it make an acute, right, or obtuse triangle? Now we've already found out that c squared equals a squared plus b squared forms a right triangle. Okay? If we're looking at an obtuse triangle, I'm just going to tell you right now, c squared is greater than a squared plus b squared means that we have an obtuse triangle, and c squared less than a squared plus b squared means we have an acute triangle. Now, why is this so? Let's take a look with an example. If I draw a random triangle, well, I'm not going to make it random, but we'll make it a right triangle where, let's say this is 3, this is 4, and this is 5. We know this makes a right triangle because 9 plus 16 equals 25. Now, if I was to make this side longer and this side longer, what would happen would be, if these were the same lengths, the 3 would go out this way, the 4 would go out this way, and because this side would be getting bigger, this angle would get bigger as well. Since this angle would be more than 90, that would make this an obtuse triangle, because an obtuse triangle is a triangle with one obtuse angle. Now, if I went in the opposite direction, if I made this side shorter and this side shorter, what would happen would be the 4 would go in this way and the 3 would go in this way. So as this gets shorter, this angle would get smaller as well. If this angle ended up being less than 90, these two right here we already know are less than 90. That would make all three angles less than 90, which would make it an acute triangle. So that's how we figure it out. If c is bigger than a squared plus b squared, we get obtuse. C squared is less than a squared plus b squared, we get acute. And this is pretty easy to remember because if it's right on, if it's equal, then it's right. If it's smaller than a right triangle, then it's going to be an acute triangle. If it's greater, that angle, then it's going to be an obtuse triangle. So, in this problem, let's see what we have. We have, I'm going to squeeze this in, 6.1 squared, and we don't know what's going to happen, so we'll put a question mark there. And we get 4.3 squared plus 5.2 squared. Okay, I'm going to need my handy dandy calculator for this problem. Give me one sec. So we're going to look at, first of all, 6.1 squared. 6.1 squared gives me 37.21, and we don't know what that's equal to, but we know 4.3 squared is equal to 18.49, and 5.2 squared, hopefully I can squeeze this in, is 27.02. 0, I'll make it a different color, 4. Okay? So, whoops. 37.21 is here, and over on the other side, if we add those together, we get 45.53. And we find out that c squared is less than a squared plus b squared. Since c squared is less, we would say this is an acute triangle. Okay? So again, first of all, we use the triangle inequality theorem. They do it 3 times. Remember, I told you you only need to do it once. So 4.3 and 5.2 gives us 9.5. 9.5 is greater than 6.1, so we're good. The other 2 aren't really necessary. So ignore that and ignore that. And then we know, since we know it forms a triangle, then we can look at classifying it as obtuse, acute, or right. So again, we do what I did. We plug in the 6.1 squared here, 4.3 squared here, 5.2 squared here. We simplify this. We find out c squared is less than a squared plus b squared. Therefore, it forms an acute triangle. Now, it says we're part of a crew that is installing the mast on the catamaran. The mast is right here, and we have these little things on the sides that are like trampolines. When the mast is fastened properly, it should be perpendicular to the trampoline deck. So how can we check that the mast is perpendicular? Using a tape measure. What we can do is we can use like 3, 4, 5 triangles, and in order for this to be perpendicular, we have to have at least 2 lines that show that it's perpendicular. So if we measure out 4 in each direction and then measure 3 up, it should be 5 for the hypotenuse. So I'll show you what that looks like. So again, to show a line is perpendicular to a plane, we must show that the line is perpendicular to 2 lines in that plane. So we're going to use 3, 4, 5 triangles and the converse of the Pythagorean theorem. So basically we measure out 4 in this direction and 3 in this direction. We see if this gives us 5 here. Okay? So we see if that gets us 5. And then what we're going to do is measure 4 in a different direction and then see if we get 5 again. If we get 5 again, then we know that it's perpendicular this way and this way. Therefore, the mast is going to be perpendicular to the deck. Okay? And then we have show that the segments 3, 4, and 6 form a triangle and then classified as acute, right, or obtuse. So again, we want to see if 3 plus 4, the 2 smaller sides, are greater than the third side. Hopefully you already know the answer to this, but 7 is greater than 6. Then we're going to look at 6 squared, and we're going to see, is it greater than 3 squared plus 4 squared. In this case, we get 36 here. We want to know, is that bigger than 9 plus 16? So 36 is here. We find out that's greater than 25. Therefore, this is an obtuse triangle. Okay? And if you notice, this is almost a 3, 4, 5, except this is 6. So since that became bigger, that means the angle opposite became bigger, and it made it an obtuse triangle. So we know it's a triangle because 3 plus 4 is bigger than 6. It's an obtuse triangle. And then it says, could you use the triangles with side lengths of 2, 3, and 4 to verify you have perpendicular lines? Well, we know that 2 and 3 is greater than 4. 2 plus 3 is greater than 4, or 5 is greater than 4, but 4 squared is not equal to 2 squared plus 3 squared. Therefore, this does not form a right triangle, and we can't show perpendicularity. I'll show why this isn't equal here. Sorry about that. Let's erase that. 16 is not equal to 4 plus 9, or 16 is not equal to 13. Therefore, this is not a right triangle, and in fact it is because this is greater, we would say it's an obtuse triangle, and we can't use an obtuse triangle to show perpendicularity. Okay? So again, no, in order to verify it, we would have to have a right triangle, and it does not form a right triangle. And that's it. Thanks.